Welcome back to the Beginning Python Challenge Day 2. Congratulations on running your first Python program. I'm so excited for you to get started today. Today we're going to dive into working with variables and libraries so that we can start building cooler programs that do more stuff even faster. I've loved getting to see your progress so far. Please make sure to keep sharing it. I love celebrating student accomplishments. Welcome. Today we're going to talk about variables and libraries, which are going to allow us to store data, work with information, and quickly add functionality to our programs to build better and cooler programs that do awesome things with way less code. So just to recap where we've been so far, this is day 2 of the Beginning Python Challenge. In day 1, we got started by displaying Hello World to the screen. If you haven't written a Python program to do that yet, please go back and complete that exercise first. Today we're going to work on variables and the turtle library, and we're going to draw a triangle to the screen. Coming up, we're going to look at loops, writing functions, and then the final day we get to put it all together and make some really cool pictures. I can't wait to see what you put together. So why variables? Variables allow us to store data in memory, also known as RAM, so that we can work with this information in our programs. Whenever you create a photo or have a video stored in your computer, it's originally stored on your hard drive. But for you to be able to work with that information, to view the photo or watch the movie, your computer needs that data in memory. The same thing happens when we write Python programs. The data must be in memory for our computer to actually work with it. Here are some example types of data that we might store in variables in a Python program. We might calculate the average runtime or speed of 5 runners. We might calculate the amount of sales tax on a purchase, or we might display text to the screen like in Hello World, which we worked on yesterday. Variables also help us make our code easier to change and modify. This is really important because research has shown that the most time we spend in developing programs is actually on changing and modifying them. So if we can speed that process up a little bit, it's definitely worth paying attention to. Variables help us make changes in one location in our program and then use that data all over the place. And then if we need to change it, we can just make that change in that one place, which is going to save us time and frustration as we move forward and build bigger and bigger programs. So let's take a look at how we create variables in Python programs. Here's an example of what's called an assignment statement, and the equal sign is what's doing the magic here. On the left-hand side, we have the variable name x, and on the right-hand side, we have the value 4. So imagine we've got some computer memory. And so in memory, also known as RAM, we're going to store names and values for variables. You can kind of think of memory like a row of mailboxes, just waiting to be filled with your data. When we execute this line of code, it gets stored in memory. X is the variable's name and the value is 4. And again, this is called an assignment statement. Not only is it called an assignment statement, it's also called a variable declaration, a variable definition, or a variable initialization. So you may see some of these terms used interchangeably when you see people talking about Python coding. Now, one thing I want to emphasize, and this is a very common misconception among beginning programmers, is this equal sign is not asking the question, is x equal to 4? That might be something you would see in a more mathematical notation. Here, we're literally telling the computer to take the value 4 and store it in a variable named x. Let's look at a couple more examples. So here's another assignment, y equals 2 plus 3. And what's going to happen here is on the right-hand side, we have an arithmetic expression, 2 plus 3. The computer is going to add that up before placing it in memory as the number 5, and it's going to associate it with the name y. Let's take another example. Oh, I don't have numbers on the right-hand side now. So we have a new variable we're creating called z, and we're setting it equal to x plus y. So what's actually happening behind the scenes here is that the computer is going to look up the values for x and y, see that they're 4 and 5, add them together to form the value 9, and then associate that with the name z. So the right-hand side is going to be executed before that value gets stored in the variable on the left-hand side. Let's look at one more example. Whoa, this looks a little bit different. If you haven't programmed before, you may have never seen this notation. So plus equals is a very common notation in programming. And what it means is it's the same as saying z equals z plus 1, as z plus equals 1. In programming, we end up what's called incrementing or decrementing, or adding a little bit or removing a little bit from our numbers all the time. And we do it so much that we created a shorthand for it, the plus equal sign. There's also minus equals, multiply equals, you get the picture. But the most common one is plus equals. So what's going to happen here is the computer is going to look up the value of z, see that it's 9, then it's going to add 1 to it before updating z's value as 10. So we're not really creating a new variable, we're creating a new value for a variable that we already had. In addition to its value, every variable also has two components, its name and its type. So with names, these are also known as identifiers, if you've seen that terminology used elsewhere. And the goal with a variable name is actually not to use X or Y as I did on the previous slide, unless, of course, maybe you're storing coordinates or you're solving physics equations, right? X and Y might be meaningful, but we really want to have are meaningful variable names that describe the contents, that describe that value for the programmer. Ultimately, your goal is not just to build programs for yourself, right? You want to share your code and perhaps even work on larger projects where you work with other people. And variable names become a way that you communicate both to your future self, right? Like imagine you wrote a program and then you look back at it 2 years later, you might be like, what the heck is going on? Or you might be collaboratively developing software with other people, and they may also need to know what your variable names mean. So having meaningful variable names is a very important part of programming, of the communication involved in programming. When we create variable names, they can use letters, numbers, or underscore, and they cannot be a keyword in the Python language like for or def. They also can't begin with a number. They can have numbers in them, but it can't be the first letter. Typically, by convention, variable names begin with a lowercase letter. If you see an identifier starting with an uppercase letter, that's used by convention by other programmers to communicate things about that value. Variable values also have types. For example, we might have strings, which you've seen before already in Hello World, right? We printed out text. So these are some examples. In Python, you can use single or double quotes to indicate strings. This is not true of all languages like Java or C. You can also have integers or ints. These are whole numbers, so they can be positive, negative, 0. You can also have floating point or decimal numbers that contain a decimal point. These can vary in accuracy, so just to be aware, because a computer is not working in the decimal base 10 system that we're used to, sometimes when you have decimal numbers and you add them together or subtract them or multiply them or divide, the numbers you get might not align with what you would calculate by hand or on a calculator. But for the most part, they're accurate enough for most people's needs. You can also have complex numbers, which, to be honest, I've never personally used because they're imaginary numbers. And so unless you're dealing with electromagnetism and some advanced physics applications, you're unlikely to see these numbers. The other type of value we work with are Booleans. This is true or false. That's it. These are the only two values that can be Boolean. There's nothing else. And notice they're not in quotes. They look like text, they look like strings, but they're actually not. They're very special values for either true or false. And so they're handy if you want to create a variable that's storing like a flag, if you want to turn a process on or off, or if you want to turn some feature or functionality on or off in your program. Lastly, variables can also contain objects or collections, so lists of data, also known as arrays in other languages. It could contain all the lines of a file or a dictionary that maps keys to values. In addition, it can represent things like turtles, which we're going to start working with today. So I already mentioned that variable names form a means of communication between ourselves and our future selves and other programmers. Next, we'll introduce a way to add additional information to our code with comments. So comments allow us to write notes to ourselves and others about our code and save hidden code for later. So we can use this in addition to meaningful variable names to help our code be more descriptive. So here we have an example program where I'm using a variable and I have lots of comments. Notice that the comments use a hashtag symbol and they've suddenly become green. The code isn't the same color as it was before. And there's a couple different ways that we can use comments. On line 4, you can see I'm hiding my code from yesterday. I don't want to lose it, but I don't want it to run anymore. And so I've commented that out. I'm also using comments to leave notes for myself. Like, this is my first program and this is my first use of a variable. In addition, in the first 2 lines, I'm also commenting a description about my program. And this is actually a best practice that we begin our programs with a description of what the code is accomplishing and some author information. One other thing I'd like to draw your attention to with this print example is we're using 2 different ways to include information in a print statement. We have a comma and we have a plus. So we saw the comma yesterday, and today we're also seeing the plus. Notice in the output what's happening. The comma results in a space by default with print, but the plus gives us no space, so I can put my exclamation point right after my name. The plus is also called string concatenation. Our final topic of the day is taking advantage of expertly written codes that we can quickly write bigger and better programs using Python libraries. Why do we want to use libraries? Well, they're the fastest way to build programs because they allow us to take advantage of code that others, expert programmers, have already written, tested, and debugged that are present in the Python libraries. So again, this is going to save time and frustration. You'll know that this is a common theme with me. I am all about finding a development process that minimizes the potential brutal task of debugging. It's a different time investment to work with libraries. Rather than writing more and testing a lot, we're actually learning more and writing less. So the balance of activities is a little bit different. But ultimately, typically we save a ton of time and we can get our code up and running doing way cooler things way faster when we use libraries. In Python, libraries are organized into modules. Here's some examples. We have math, which has traditional mathematics functions like square root, floor, log, sine, the constant value pi, etc. There's a statistics library package. There's a random library that allows us to generate random numbers within a given range. There's also a web browser, a regular expression library that allows us to do text processing really easily. And finally, what we're working on today is the turtle library, which allow us to use very simple commands to draw really cool shapes on the screen. We can take advantage of libraries in our Python programs by importing modules, and we need to use the import keyword. And we can do this in one of 2 ways, and it changes how we call the functions. So it is important to understand which way you're using and what the implications of that are. So let's look at some examples. Here's our example template. We can either import our module or use the command from module import function. Let's look at an example using the square root function from the math module. So on the left, we have import math, and on the right, we have from math import square root. And as you can see, the code where we're calling the square root function looks a little bit different between these 2 examples. So let's unpack this a little bit. So import is our keyword, math is our module name, and then we have our library call. And note the dot, the period I'm using in between my module name on the left and my library function on the right. When you import math and you import the module, you have to type the module name dot the name of the function. Now, I actually prefer this way because I will often develop code in something called PyCharm. And when I do that and I type the dot, it automatically pops up with a listing of all the functions I could use. Trinket, which we're using for the purposes of this challenge, does not have that capability. So depending on what IDE or development environment you're using, you may actually prefer to import math and have to type the module name. It may give you added features. In the example on the right, we have the keyword from, the module name math, the keyword import, and then the name of the library function. And in this example, our library function call is simply the name of the module function that we're trying to access. So you can really choose between these 2 ways. On the right, We write a little bit more on the import line, but we also have a very short function call where we don't have to type the module's name. So are you ready to try out these ideas? Let's get to it. So please open up Trinket. If it's not working, there's a couple other examples here that you can use. If you don't have a blank program in front of you, please remove any code that you haven't written. What we're going to do today is draw a triangle using Python Turtle. So please see the worksheet for details, and I've also shared a video solution. I can't wait to see you for day 3, where we learn how to use loops and to automate repetitive tasks. Please, please, please share your progress. I can't wait to see what you're creating.